for 22 through 26, since these are log equations, we're going to end up exponentiating at some point to eliminate the log. So for number 23, since each side of the equation has one log, we're allowed to exponentiate and have it actually cancel the logs. So since these are ln, we want to exponentiate with the base of e. So we'll exponentiate both sides, and since there's only one ln, they'll cancel. So the left side becomes negative 2x, or n, or whatever, minus 1, equals negative 4x minus 7. And so now it's just a linear equation, and we'll solve however we solve a linear. So get everything to one side, divide, blah, 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 and we'll get, in this case, we'll get that n equals 4. I mean, negative 3. All right. For 24, it's very similar. Since each side of the equation is just one log and nothing else, just a log, we can exponentiate. In this case, we want base 15 because then those logs would cancel and we will be left with just the inside of the logs. Here we'll move things around and we'll get that x is 0. For number 25, so 25 we have 2 logs, so let's do something a little different. So if we have 2 logs, we can't exponentiate because there's no property that deals with having multiple logs. There's no way to cancel if you have multiple logs. We do know, though, how we can combine 2 logs, and that'd be using the product or quotient properties. So since we are adding these 2 logs, that's equivalent to the internal product. So x times x plus 12. So now that there's just a single log, now we can exponentiate. So we'll base 4 because it's a 4. So the left side will be x squared plus 12x. The right side will be 4 cubed, which is 64. So now that it's a quadratic, we'll set it equal to 0 and solve. When you do that, you're going to get 2 solutions. You would get that x equals, I believe you'd get 4 and negative 16. Now, we have to see if they both work because you cannot log a negative number. And it looks like if you plug negative 16 in, you'd be logging negative 16, and that's undefined. So the solution is only 4. For number 26, 26 is similar to 25 in that we start with 2 logs. So we can't do any kind of canceling yet, but we can combine. So we can combine both of those using the quotient property, because it's a minus subtraction. So that 2 goes in the denominator. And now we can get rid of the log because it's just a single log. So we can base 10 both sides, because if we don't see the base, then it's the common log, base 10. So we're left with x squared minus 7 over 2 equals 10. And then we can solve this quadratic. Multiply both sides by 2, add the 7, take the square root. So positive and negative radical 27, which reduces to 3 root 3. But like the previous problem, we'd need to check that they both work, if they both work. So if we plug this in, well, in this case, we're squaring the answers. So even if it's a negative x, it's going to be squared and become positive. And those positives minus 7 are both not negative. So in this case, both of them work.